Hello everyone, class 12. This session is for you. Today we will discuss on the chapter only. This is the remaining chapter. Today I will start the chapter through this video mode, and then when online class will be started that day we'll start 4 marks questions. Okay. Now let's start. Definite integral as an area. Definite integral as an area. Okay, this is our topic today. Still my finger is not, what will I say, yes, better than before, but still it's penning is giving me trouble, so I can't write properly on board. I'm trying my best in spite of that. Okay, now the first part is the definite integral as an area. Now what type of area we have to find. We have to find the area, that means area one curve will be given between the curve and the x-axis, curve and the y-axis, or two curves will be given. That also we have to find between two curves what is the area, that also we can find. Okay, now the first one is area under the curve. Area under the curve, what does it mean, under the curve? And number two is area between the curves. Area between the curves. Okay. Now area under the curves. At first we will discuss this part. Area under the curve. Let this is x-axis. We know this is y-axis. Okay. Now if I draw a curve like this, y is equal to say fx. Okay. And let us draw perpendicular from this point, draw another perpendicular from this point. Okay, let this point is this line x equals to a, and this is the point x is equal to b here. We have to find the area under the curve and above the x-axis. Above the x-axis, under the curve, that we can see. Now how to this is y is equal to fx. Question is y is equal to function of x. Okay, the question is area, this part, area of this curve, area under this curve we have to find, under this curve and above the x-axis. So between x-axis and this area, what we will do? So if we can draw what to do actually. Actually, what we are doing, let me draw one strip like this. We can take this one single strip like this. So if we can find the area of this red strip, this is a rectangular part, we know this is a rectangular, and this height of this rectangle, or length and breadth, we know area of the rectangle is what? Area of rectangle is length into breadth, that we know. Here length is, we can consider this also. So this is y, this width is y, so we can write this as y. And if we take this width, that means this is breadth wise, this is very small change of x, let us take this is as delta x. So we can write y into delta x, or we can write delta x, or we can write this as dx also. We can write this delta x, or we can write this as dx also. Now dx, so we can write y dx. We can write y dx. So with respect to x, when we will find the area of the curve, we will write y dx. Similarly, when that also I will show, when we will find the area of the curve with respect to y axis, that time we will write x dy. What will be the diagram of that type of Let me draw the diagram first. See if we draw like this curve is this. Yes. Now we have to find this area. Same as before. That means when y-axis and the curve is there. So y-axis and the curve, between y-axis and the curve area is this. So we will find. Now same thing here. We can take a small strip here also we can take. Okay. Now here this is equals to x. Okay, and this part is change of y. So this part we can take as let this point be y equals to c and y equals to d here. Okay, and this changing we can write as dy. Okay, and this is all we know, this is the width for x. So this is x. So what we will write here, area of rectangular part, rectangular strip actually, area of rectangular part. What will be the area? What did I say? Length into breadth. So here x into dy. So it will be x into dy. Got it? Now, the point is when we are to find the area of the whole region. So many strips we can draw like this. Here we can draw, here also we can draw. So many strips, that strips should be between A to B. Those strips should be between A to B here. So if we want, we know area of the shaded region, in that case what we will write, we will take this integration part. Why integration? Because we use this integration for the summation, that we know, summation within A to B. So A to B and this y equals y into dx, and here what we will do, here it varies from C to D, all the strips like this, but it should be between C to D. So between C to D we will take an area, here it is x dy. This is with respect to y-axis. So this is with respect to y-axis. Okay. Okay, and this is with respect to x-axis. Clear? This is with respect to x-axis. This is with respect to y-axis. I think now it is clear to you. Now, how to... Right now, see if the question is, say the curve is, say y is equal to, if I take the curve as y is equal to x square. If I take a curve, say y is equal to x square. So in that case, what we will write? X is equal to root over y. X is equal to root over y. So if we want to find the area of this function, so with respect to y-axis, what we will write? C to D. And here, instead of x, we have to represent in terms of root y, because dy is there. Then we can expand easily. Okay. Next. Let me rub the board. One more example I will have. Now I think now this is understood. If it is with respect to x-axis, then it is coming y dx. If it is with respect to y axis, it is coming x dy. Remember this, it is very, very important. Okay, now, okay, next carve I'm explaining from the next new video. Thank you.